Hello. In this video, we'll be looking at triangle problems. Basically, we're going to look at applying our knowledge from the previous parts of this chapter, where we looked at cosine rule, the sine rule, and the area of a triangle, into sort of more complicated problems, where we'll be linking and using multiple different formulas. So, as a recap. Let's draw a generic triangle. Right. There we are. So firstly, if we call these two sides A and B, and then we have this angle capital C, then firstly we can say the area of a triangle, when we're given two sides and an angle in between them, like this in this case, we can say the area of the triangle is then a half AB sine of C. And so that's the area. If we then wanted to work out the other side, which would then say be little c, that's big C, the angle. That's little c. So then we can work out this side C via the cosine rule, right? Because again, if we know two sides, A and B, and the angle in between them, side facing the other side, which is facing the angle, in this case, we can use the cosine rule to work out that. And that says c squared then is going to be the upper two sides, all squared. Take away two lots of AB, cosine of the angle C. Right, so the cosine rule is used in the case of three sides and an angle. And in particular, when you know two sides, in this case A and B, and the angle between them. And then obviously the other side as well. The cosine rule is for three sides and an angle, if we're dealing with three sides and an angle, like in this instance. Okay, what if then I have this other angle here, I'll call it a capital A, because that's the angle opposite the side, little a. But then in this case, we can find, if I get rid of this B, okay, I don't need it, I can use the sine rule to work out these angles or sides, right? So then the sine rule is instead, if we have little a, which is length A over sine of big A, is going to equal C over sine of C. And actually, if we had this side B and the angle opposite it, capital B over here, it would also be little b over sine of B. So that is the sine rule. Where we can relate a side and the opposite angle to that side in this way. And the core idea, if I just get rid of this then, or I could just say B over sine B, which I think is what most people are familiar with. And the sine rule we use is to work out a missing angle or side. In the case when we know two sides or dealing with two sides and two angles. So the crucial difference between the sine rule and the cosine rule is cosine rule is three sides, and we're only dealing with one angle. The sine rule is only two sides we're dealing with, okay? And with either rule, you can work out either a missing angle or a missing side, but the idea is the conditions are different, right? The cosine rule, again, is three sides and an angle. The sine rule is two sides and two angles, okay? So that's just a rough recap of the three formulas we'll be using in this section. Questions most commonly will probably be requiring you to use multiple of these. Let's have a look at some exam questions there. Right. Okay, we are told the diagram below shows the locations of four mobile phone masts in a field. DC is 75. Okay, they've given all the information there. I'm not going to read that out. In order that the masts do not interfere with each other, they must be at least 70 metres apart. Given that A is the minimum distance from B, find the distance A from B. So we want to find this side A from B, which is this left side here. I'll call that X. Well, actually, one thing immediately we can do, based on this information, bit weird. They said that that mast, which are basically the points A, B, C, and D, they have to be at least 70 metres apart. That's the minimum distance. The total A is the minimum distance from D, which is this length here, A to D. So if that's the minimum distance, it has to be 70 then. So we can fill that in as well. A bit confused with I guess a little bit of problem solving there, but a bit weird. They didn't give it right away, but there we are. So we've got another side to add on. Okay, so we need the distance A from B, so we need to find its x essentially. Okay, so the problem is we don't have any triangles. And I know we're going to need to consider triangles. We've got a mixture of sides and angles. So I'm going to need to create triangles from this. And with this sort of, when you got like a sort of quadrilateral like this, the best way to do this is to go through the diagonal. So I could go here, BD, all there. And so, but I want to go. I'm probably going to want to use the diagonal BD to create these two triangles, right on the left and right side of it. I wouldn't want to use this diagonal AC because if I did that, actually, no, I could actually. It depends what your preference is actually. But I'm going to stick with here. Because I have two sides and an angle here, so I can work out some information based on that. So I'm going to start with this triangle here. Here. So that's going to be triangle BCD. Right, so that's the whole idea of these sort of questions. If you've got some sort of quadrilateral or some sort of shape, uh, you're probably going to want to create triangles, right? By perhaps splitting it somewhere in the middle, so through the diagonal. Okay, so we've got this triangle here to work with first, BCD. So if I draw that then, I have this particular type of triangle. So that's B, this is C, and that's D. I know this angle's 55, I know this is 75, and that's 80. I don't know this angle. Obviously, you know the whole angle is 140. But the problem is we split it. We split it. We split the angle up, right, in this case, and it doesn't necessarily split it halfway equally. It doesn't bisect it, so you can't say it's 70. Because we don't know anything about the type of quadrilateral it is, right, or anything like that. So we can't assume anything there. So we don't know this angle, so we don't include it. So this is the information we have, this little triangle here. We know the angle 55 and the two sides, 75 and 80. So what can I work out here? So this is what I'm going to be thinking with these sort of questions. What can I work out with this information and then go from there? Well, I've got two sides and an angle next to it, right? And I want to work out lengths, right? I want to work out an x here. So I'm going to be considering either the cosine or the sine rule, because those two rules tell me stuff about the angles or distance or something. Okay. So again, I've got two sides and an angle. And in particular, the angle is in between the two sides, right? So if this angle is facing or opposite the other side, BD, that means we can use the cosine rule because then I can work out this other side, right? So this side BD squared then is going to be the two sides all squared. Take away 2 lots of 75, lots of 80, cosine of 55. If I do that in a calculator, I get 5,000 and 42.082 dot dot dot. And so then if I square root both sides, I get therefore the side BD is this 71.7083 blah 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 meters, right? So now I've got BD. The problem is, we're going to need to use this side because we're going to need multiple different formulas, right? Multiple cosine rules or sine rules, whatever. We are going to need to use this large infinite decimal. So you can do this. So if we were reusing previous answers like this, so we're using this side BD again, which here again is 71.7. You could either write down like all the digits in your calculator and then reuse that number when you wrote it down, or you could store the answer in your calculator, which I think I'm going to take the time to explain now, because it's quite a handy tool once you learn it. So this is another calculator demonstration just to help with this. So storing answers then. So firstly, I'm going to retype this calculation in my calculator. So 75 squared add 80 squared minus 2 lots of 75 80 cosine of the angle 55. That's what we did. And so we get this 5142.082. So you know I'm not lying, but that is the number you get. And then obviously we square rooted our answer. And then we got the 71.7. Now, like I said, you could write all the digits in your calculator because we will be reusing our answers to work out other lengths or other angles. But then we're going to look at the stored feature in the calculator instead, which get used to it. I think it's far better. So I'm going to click this S2O button in the sort of the bottom left of the black keys, right? This STO, this store button, is what it stands for. There. And so then I'm gonna then if look at the red letters on the row above it. So you got A, B, C, D, E, F, where it has the minus, the quotation marks, the X to the minus one, the sine, the cos, and the tan buttons. If you look above that in the red buttons, which we call the alpha mode, with A, B, C, D, E, and F, we can assign any number like this to one of those letters. There are more letters as well, but we don't need more than 6, right? So I'm going to store it as A, right? Just the first letter, A. So there we are. So now when I click the button there, which is A, the letter A, which is in red on that key, that stores that number is now assigned to that button, A. Right. So then, if I then want to, if I get rid of all this, if I then want to access that same number, I then need to go in alpha mode or red mode, which is here, which you can, and then I can press the button of the letter, right? So that's the button A, which is what I assign the letter to. And so it gets me that same number with all the decimals there, right? So if I can quickly store my answer with any of these letters, sorry, A, B, C, D, E, and F, which are red letters, in this way, and then I can access that again by going in alpha mode and then clicking, that same letter. So that's going to be useful. So now I realise now I should remember I stored that as A in my calculator. So if I need to access this number again, I don't need to type it all out. The calculator has stored it for me. Okay, so this store feature will come very handy with multi-step problems like this with multiple sort of calculations to it. But okay, so we've got this length AD then for now. Okay. So then this bit again we can sort of annotate our sort of triangles that we have. So that's 21.7 then. This is going to be 21.7. So what can I work out now then? Now bear in mind again, I want to work out this length x. So again, I need to consider the triangle ABD, which obviously again I've drawn here. So I've got this triangle to work with. But the problem is, actually, I know this side BD now is also 71.7. So I've got three sides, so I'm going to need an angle then, right? I'm going to need an angle because I can use the cosine rule. But I need to know an angle then, don't I? If I need to work out this missing side X, I need to work out, well, this angle here, right? Or any angle actually, but I need to work out an angle in a triangle. But I don't have any angles in this triangle. So then I need to go back to the drawing board, right? So I need to work out either this angle, that angle, or this angle here. But I think this angle I could work out because I know something about it. I know between these two angles is 140, right? Between the two triangles, overall it's 140. Well, if I then work out this angle and this triangle, I'll call theta, say, well then can't I just do 140 take away that to get then this part of the angle? Well then there we are. So can I work out this angle theta then? This particular angle there, which I'll label here. Well, I can because I know a lot of stuff about this right triangle, this triangle BCD, because I know all three sides. So if I can work out missing angle with three sides via the cosine rule again. So there we are. So as this angle theta is facing or opposite to 75, and it's in between the other two sides, 80 and 71.7, I can use the cosine rule to say then that this 75, which is opposite the angle theta, 75 squared is 71.7 squared plus the other side 80 squared. Take away two lots of 71.7, 80 cosine of theta. Okay, so I actually think it might be best to sort of rearrange first before we work out any numbers on our calculator, just in terms of cos theta. So then cos theta then, well firstly we're going to have 75 squared, then we're going to have to take away 71.7, take away the 80 squared, and then we're going to divide by this, right, divided by minus 2 lots of 71.7, 80. Right, so then that's cos theta, so then I can just put all that in the calculator. So if I put that in the calculator then, but this is where this store function I talked about is going to help me, because this 71.7, that is the ongoing decimal that I worked out here, right? So I can just access that very quickly on the calculator, right? So if I go back then, so then cos theta, so it's going to be a fraction, there we are, then we're going to have 75 squared, take away the 71.7 ... Now that's the decimal that I stored, right, under A. So then to access that I need to go into the red mode or alpha mode to press the red letter A there. And then that'd be A squared, which is 71.7 squared, minus the 80 squared over minus 2 lots of, again that's going to be A. So again need to go in red mode, then click A. As the A represents the 71.7 times 80. Okay, so if we do that then I get cos theta is 0.5157 ... right? So then if I do inverse cos, then theta is, so remember inverse cos then, I need to go in the yellow mode or the shift mode because inverse cos is in yellow, and then that's my previous answer. And so then it's 58.95 ... 594 ... Wait, what? Yes, 954. Okay, degrees. Now again, I'm probably going to need to store that answer as well. Okay, and that I might need the angle. So then I'm going to do ons, and then I'm going to store it as the letter B then, the next letter. So there we are then, and then I'm going to store that nasty decimal. So that's theta then, which is 59 degrees, right, if I round it, but obviously it's not the full answer. But there we are then. So that's 59 degrees. So now I work out that angle. So then I can work out this angle then, this angle ABD. So then angle ADB, which is this part of the angle of the 140. That's going to be 140 take away that angle, the other angle, right? So I can put that in the calculator. 140, and then actually this 58.9 was my previous answer, right? So we get 81.0459, blah blah blah. So that is now this angle here, 81.081, I'd say, right, degrees. There. Okay. 81 degrees. And again, because that's another decimal I might need to use, because that's not my final answer, right? I can then store that as another number, right? I can then store that as, say, the next letter C, right? So there we are. Then again, if I access C, then it gets me that angle. So there we are then. So that's 81. And again, if you could help them if you think you're gonna forget, you can note what you can note what you stored it as, like this, if you wanted to. But anyway, so that's what I stored it as. So that's the angle ADB. So if I go back to this triangle then here, but then I'm in a position now to work out this to the letter X, right? Because then I'm dealing with three sides and an angle, which I now know. So I can find the missing length X by the cosine rule again, right? So if I do the cosine rule here then, now X squared equal the other two sides squared minus 2 lots of 70, 71.7 cosine of the angle 81 degrees. So if I put all that in the calculator, and again, this is where the store function is going to be very handy. So I'm put all this in the calculator then. So 70 squared. Now the 71.7 again is that large decimal here, which I actually stored as A again, if I remember. So to access the letter A, I'll go to the red mode, alpha, and then click A, and then that'll be squared. And then minus 2 lots of 70. Then again, 71.7 is that A again, that large decimal is stored. And then the cosine of this angle 81, but again, it was this large angle here, ADB, which I stored as C, right? So then I need to access the the red mode again and go to letter C, the red letter C. And so there we are then. So I'm going to equal all that. It calculates X squared to be 8479 0.559, blah 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 blah. So then to get X then I need to square root both sides. Oh. And I get 92.08 4 blah 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 meters. I could round that then if I wanted to. 92.1 meters to 1 decimal place. Okay, cool. Now again, that's only part A. I might need to use that working again, so I'm going to store that then as D, right, the next letter. So I'm going to store that as D then. There we are. Okay. Right. So then I now know that xn of what, which is the distance from A to B. So that's part A done, which is 92.1. And again, I can start to fill in my triangles here. Right, okay, let's jump back in then. So we have part B then, which says work out the angle BAD. So the A is in the middle here, so it's the angle at A. Okay, so I'll call that capital A then. So that's the angle at A. So if I go back to the triangle, say down here, then it's here, right? So how am I going to work out this angle A? Well, I'm sport for choice because I know I've got two angles, but I also know all three sides. So I could use sine or the cosine rule in this case. But I think I'm going to use the cosine rule because I've already dealt with the three sides, right? So I can use the three sides and then work out the missing angle A. So as the angle A here is facing the side 71.7, I'm then going to say that 71.7 squared is going to equal the other sides all squared, 92.1, add the 70 squared, minus 2 lots of 92.1, 70, cosine of A. Now, it is best to rearrange at this point for A before putting any numbers in, because if you do that, you can create more decimal than you need than you want to deal with, right? So let's rearrange here before we get any more nasty decimals. So if I rearrange the cos A, so cos A then is going to equal this 71.7 all squared, 71.7 squared. Take away the next two numbers here, and then divide by this. So then we'll be divided by minus 2 lots of 92.1. And remember, you could also memorise the other formula with the cosine rule, which was cos A is b squared plus c squared minus a squared over 2bc. Or you could rearrange it with the sort of like default cosine rule, right, which is what I've done here. But they're the same thing, but it makes your life a little bit easier if you learn that formula as well. But if you know how to rearrange, then you can just jump in like I did here. Okay, so now I can just input that in the calculator, right? And again, this is where the store function is going to help. So if I go back to my calculator then, so firstly, I have to compute this division. So fraction, and then 71.7, again, that's A, right? That's what I stored as A. So go to my red mode, and then click the red letter A, and let that be squared. Then I'm going to take away the other two numbers, 92.1. Now again, this 92.1 is actually this large, is this large decimal here, 92.084, blah blah blah, which I've stored as D, right? If you remember. So then it's going to be the letter D. So red, and then here. So then take away D squared minus 70 squared divided by minus 2, lots of 92.1, which was D again, and then times 70. And so put that in the calculator, I get this 0.6, cos A is this 0.6389, blah, 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 right? So then I can just do inverse cos, so therefore get A is the inverse cos, which again I need to go in yellow mode or the shift mode of my answer, previous answer. And so I get 50.285 blah, 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 degrees. If you can round it if you want to, 50.3 degrees to 1 dp. Okay, it doesn't specify what to round to. That's quite an awkward question. This is very awkward numbers. They're not normally this bad. But there we are. I've got the angle then. Right, so then part C says, find the area enclosed by the four mass. So we want the area of the whole sort of shape, right? So in other words, we want the area of both triangles. Right, okay. Trying to think how where best to do this. So I'm going to redraw the triangles I've already got, right? Right, so I've drawn the two triangles. So we basically need to work out the area of both of them, right? Because obviously, as we said, we split, when we draw the diagonal here, we split it up into the left triangle, right, and the right triangle here. So we need to find the area of both triangles to give the overall area of the shape. So in other words, area of these two triangles. Now we've already worked out a lot of stuff of information regarding the sides and the angles. So remember, in general, the area is a half AB sine C. So if we know an angle and two sides in between, an angle between two sides that we know, then we can work out the area of them. Well, this one's quite easy, right? Because I've got the angle 55 here and the two sides 75 and 80 next to it. So the area in this case, an area of triangle BDC, which is the first one, is then going to be half of times by those two sides, 75, 80, sine of the angle 55. Now none of those are long decimals because those were the original values given in the question, 75, 55 and 80. So no need to go to like my store function of a calculator. Then I did not, these are the original numbers provided. So if I just work that out, times 75 times by 80 times by sine of 55. So if I put that in, I get 2457.456. Blah 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 meters squared. Now again, that's quite a large decimal, so I'm going to store that as well. Store it as A. That's it. That's my answer. Oh, there we are. So I'm going to store it as E then. I haven't used that letter. Oh man, there's a lot of decimals in this question. Okay, so that's the first triangle done, and the area of this then. So again, I've got this angle 81 in between these two sides, 71.7 and 70. So then the area of that then, and now this 81, remember, is this decimal, this here, this the angle here. So it is a large one, which remember I've stored as C in my calculator. But the area in this one, so the area of triangle ABD, triangle ABD up here, is going to be a half times 70 times by 71.7 times by sine of 81 degrees. So if I put that in the calculator then, I get a half times by 70 times by 71.7, which I've stored as A, that large decimal. So I need to go in my red mode and then click the left button A. And then the sine of 81. So that was that decimal C. So I need the red mode, click C. And so I get 2479.205 blah 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 meters squared. Right, so then the overall area, or total area, is going to be these two added together. So I can add this by the other answer, which I stored as E, remember previously, which was this 2457. I get overall 4936.661 blah blah blah, which I can round to 7 to one decimal place. Okay, there we are then. So that's the whole question done. A very extremely nasty question that is. I guess the maths is a bit tricky, but also just the numbers. Like so many numbers you need to store in your calculator. If you didn't store it, you'd have to write them all down. I think. I don't see a more efficient way of cutting down the working. I don't think. So you'd have to. So we'd have to reuse the numbers, right? And they're really awkward and large decimal numbers. So we did need to store quite a lot of numbers in my calculator there. But hopefully, you sort of nice little calculator sort of tip that is. When you need to reuse numbers in your working, you can store that in your calculator. So you don't need to write down large numbers on paper or on your calculator. So you can save time by just storing answers. So you can reuse them whenever you want. Yeah, so not the nicest question, but hopefully that sort of made sense. So that's the old idea, right? We can combine and work out missing sides and angles, and then I can go from there to work out other sides and angles to get to what I want, essentially. Okay, let's have a look at some exercises. Let's have a look. Okay, this one's much more simpler, I think. So we are told in this triangle, cosine of the angle ABC. So angle is at B because B is the middle here. I can call that. I won't call it a number. I'll say I'll mark the angle there. And so the cos of the angle is 5/8. Calculate the value of x. So first of all, you're probably thinking, why have they not just told me the angle? Why am I told that the cos of the? If I call this theta, then right. I'm basically saying cos theta is 5/8, but they've not told me that theta is what theta is exactly. If I put that in the calculator, if I do inverse cos, it tells me theta is 51.317. Now that again is an infinite decimal. But the problem is, we'll get into why they only told me cos theta and not theta in a second, but it's because it's a large decimal, so we can't write it nicely. But anyway, part A then says calculate the value of x. So x is a side here. Well, we're in a situation again where we've got three sides and we've got something about the angle here. So it's going to be the cosine rule, right? So this angle theta is facing this side, x plus 1. So then we can say x plus 1 all squared is going to equal 6 squared. Add 2 squared, take away 2 lots of 6, 2 cosine of theta, or angle ABC. Now, this is why they told us the value of the cos of the angle, not what the angle is. Because we don't need to know the angle. We just need to know what cos of the angle is. So we can get the value nicely in this way. So if we simplify this, x plus 1 all squared, well 6 squared and 2 squared is 40. Okay, nicer numbers this time. And minus 2 times 6 times 2 is minus 24 cos theta. Well, cos theta is 5/8, right? So we can substitute that in. There we are. And so yeah, so that's why you will see questions, especially when we look later on in the course, when we look at more trigonometry and stuff like that. They tend to give you the cosine of the angle rather than what the angle is, because if you did the inverse cos like we did here, the angle would be quite nasty. But the cosine of it's quite nice, right? It's 5/8. That's exact. But this one isn't exact. We can't get the exact value of the angle. So it makes the computation here a bit more awkward if we try to find theta, which we don't need to. So we just need cos theta. So there we are. We plug that in essentially for 5/8. And there we are. So then we can expand this bracket. So x plus 1 squared, well, that's going to be x squared. Then x and x would be 2x. And then 1 squared is plus 1. Then we're going to get 40 and then minus 24 times 5/8. So I'm going to get minus 15. There we are. So then, actually then, this 40 minus 15 is actually 25. But then I can move that to the other side to get a quadratic equation, can't I? So then I'm going to get x squared plus 2x. And then 1 minus 25 is minus 24 equals 0. And then I could then I could solve it by the formula. I could maybe swap some factors to factorise, but I'm a bit lazy for that. So then xn is going to be minus 2 plus or minus the square root of 2 squared minus 4 lots of 1 minus 24 over 2 lots of 1. And there we are. Put that in the calculator. Where we get x is 4 or minus 6. So again, I've got two possible solutions here. However, x plus 1 here is a side. It's length. Length cannot be negative, has to be positive. So that means x has to be positive because x is a side, right? So x must be positive. So therefore we need 4. We can't have minus 6, right? So therefore x is 4 in this case. So there we are. So we found the value of x then. Cool. Then part B then says find the area of triangle ABC. Right. So then if I do it up here, well, x plus 1 then, well, if x is 4, then 4 plus 1 is 5. So we're in the case then where we got two sides, 6 and 2, and the angle between them, theta. So I'm gonna then have the area then, which is a half AB sine theta, or sine C in general. But then the two sides is going to be half times 6 times 2, the sine of theta. Now, so I can simplify this bit firstly. So half times 6 times 2, so that's going to be 6 sine theta. Now, this is sine theta, not cos theta. So we're in a bit of a pickle there. So we probably are going to need to use the angle theta and then do the sine of it. Now there is a way you can bypass. When we look at the next chapter, there is a relationship between cos and sine where we don't need to explicitly work out the angle. But for this earlier chapter in the course, I'm not going to do that. So we're going to just try and find the angle theta. So therefore, sine of this angle, if I put that in the calculator, it's going to get me. So I did have to work out the angle theta then, I guess. But we try and avoid extra work whenever you can. That's what I'm saying. Anyway, if we do sine of that, sine of 51.317, I get 0.7806, blah blah blah. So that's the value of sine theta then. So it's going to be 6 lots of this 0.7806. So if I do that, I get 4.6837. No units, okay. Units squared. Or I could say it's 4.68 units squared to 2 decimal places around it. There we are then. So that's the area then in that case. Okay, cool. Look at another example. Right. Here we are told two radar stations, A and B, are 16 kilometres apart and A is due north of B. A ship is known to be on a bearing of 150 from A and 10 kilometres from B. Show that this information gives two positions for the ship and calculate the distance between two positions. Okay, so you're probably thinking, what on earth is going on here? So it's best to break it down, right, and part by part and try and spot where the points are roughly. So we're given two radar stations, or 2 points A and B, and they're 16 kilometres apart, so the distance between them is 16, and A is due north of B. So if I plot B then, somewhere, right, A is due north of B, so A is north of B, so it's upwards. So it's just completely upwards, right, in the north direction. And if the distance is 16 apart, so A is going to be on top of it, like here, with a distance of 16. Right, there we are. So that's the first bit. The ship is known. So the ship is something else now. The ship is known to be on a bearing of 150 from A. So then if we plot where that bit of information, the bearing. Now again, bearings, if you have a point here, say X, so a bearing is a special type of way of measuring an angle again from B to C. And we did look at an example in an earlier chapter where it's basically an angle that's measured starting from the top, right, from this north direction. So when it's upwards, and then the angle between them, that angle then from the north point represents the bearing, right? So if the bearing is 150, so that's going to be 90. That the bearing here will be 90. So 150 is going to be a bit more than that. So it's going to be about there, right? That'd be 150 there. So in that case, then we want if upwards be that way. So if 90 would be there, then 150 would be about there, right? So then that whole angle is 150. There, so that's 150 degrees. So this is where the ship is on this line here. So if we call the ship, say there, shall we call that point C then? I guess it makes sense. So I'll say C is where the ship is. So 150 there, and it's 10 kilometers from B. So if I then join here, that's 10 there. Okay. Now actually, I can work out this angle, so can't I? Because overall, those two angles have to be 180. So if I have 150 outside of the triangle, then this angle has to be 30 then. And there we are then, so I can kind of get rid of that. And so then we just got a basic triangle, right? So there we are then. So we plot the information in, so it should be a lot easier then to deal with now. Sort the scary bit over with. So we need to then use this information to give two positions of a ship. Now remember, the ship is the point C here. Okay. Right. So what can I work out at this point? So I've got two sides and an angle. I could use the cosine rule. Or could work out an angle. So I could work out either or. I'm going to need to work out both, spoiler alert, so it doesn't really matter what we start to work out. But it's firstly talking about the position of the ship, so where C is. That's referencing the angle, okay? So the distance is going to be the length here. I'll call that X. But the angle here at C would give me the position, where it is roughly. So if I call that angle theta then, so that's what I'm going to start to work out then, right? So firstly, well, to work out this angle then, I've got two angles and two sides. It's going to be the sine rule, right? Because that's what the sine rule is about. So then if I have the angle theta, so then the 16, that side 16 is facing it. So we're going to have sine theta over 16. And then the other angle we got is 30. And that's opposite the 10. So we're going to have sine 30 over 10. So therefore then sine theta is going to be 16 times that. And so if I work that out on a calculator, I get 4 over 5. So therefore theta then, if I do inverse sine, I get 53.13 blah 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 degrees. But because it's sine, we need to consider the ambiguous case because there will be two solutions for theta here. So to help see that, if I consider the sine graph between 0 and 180, and I did a lot of work on this in the previous videos in this chapter if you're a bit stuck about this ambiguous case about finding the second solution. But if we go between 0 and 180, well, 53 here is going to be about roughly there. Therefore, the other solution will be there. So then this other solution then, because the idea that the gaps at either end, here and here, are the same, so and the end here is 180, then the other solution would be 180 take away this, right? So if I do that in the calculator, I get 126.869, blah, blah, blah. Okay, but then I need to then check if this is a valid solution, this second solution, and it is in this case, because if I add this to the angle 30 in the triangle, I would get 156.869. 156 is below 180, so we can have that angle as well. And that does make sense because it's talking about two positions. Now, these two angles will indeed give you two different positions because they're two different angles. So what we've effectively got then is two different triangles because we've got two values of this theta here. So the first one, if I draw it here, A, B, C. So that angle when theta is 53.1, say. So that's 10 here. This is 16. Right, and that's 30. Or we'd get this sort of triangle. So AB again is here. And 10. So then it would look perhaps a bit like this. So then that'd be this 126 here. And that'd be 30 there. And so, no, that'd be 16, sorry. And this will be 10. So there we are. So we've got two sort of different triangles based on the angle, right? So one's acute, which is 53, and one's obtuse, which is 126. So two different angles produces two different triangles. And so crucially then, the length here between A and C, if I call this X here, they would all to be different values, right? And hopefully you see one will be bigger than the other based on our diagram. So yeah then, so this leads into the idea of two different positions because of the idea we essentially get two different triangles based on the two different angles we get, right? So there we are then, so we've got the angles, so then it's asking for the distance between these two positions. So it's between these two positions then, so it's basically asking for the difference between the distance here and the distance here. If you imagine, because A and B are on the same, they're still the same, right? On the same point. It's just that C is a bit, again, because the angles are different, it has a slightly different positioning. So if we draw, this would be this C here. We'll call that C2 if you want to, and C1. And then C1 is further along. So if we continue with the triangle, C1 will be there, right? So essentially, we almost got two different triangles, right? So that's angle 126, and this is angle 53.1, right? So hopefully that visualizes to you that there are two, that exactly what the two different positions are. That's what it would look like, right? These two triangles create these two sort of situations where how further along this point is on that line, right? This line between A and C, right? And so obviously you can see the distances will be different as well. And so the distance between the two possible points is indeed this distance here between the first C1 and the second C2, right? I can work that out then, because I can't. If I work out the distance between A and C1, and then the A and C2 here, then I can sort of work out that. So then I need to consider this side then, this length AC1 here. I can call that X then, and I can call that Y if I wanted to. So to work out the X then here in the first triangle, I probably could do the cosine rule, right? Because, well, I can work out this angle, right? Because it's facing the X. Because I can do 180 take away the other two, right? So if I do angle AC, no, it'd be ABC1 here. Then that's going to be 180, take away the 30, take away this 53.113 dot dot dot. Okay, right, this is when I'm going to have to pull up the calculator again now, because I'm going to need to reuse my previous answers, right? So, this 53.13, 180, take away the 30, take away my angle here, I get 96.869. So then I can store that, right? I can store that as answer A. Right, so that's 96 here. So therefore then, if we use the cosine rule to work out the x here, then it's going to be x squared. It's going to be the other side, all squared, so 16 squared and 10 squared. Take away two lots of 16, 10. Cosine of my angle, this 96.869. And so if I put that in the calculator, I get 394.276. Blah, blah. Therefore, x then, square root it, I get 19.856. Blah blah blah. Meters, is it? Kilometers. Okay. Kilometers. So I can store that then as, say, the next letter B. There we are. Right. And so I can then do a very similar process to find the length y here. So I can use the cosine rule again because I've got all three sides. So then I need to work out this angle then firstly, as it's opposite that length y. But I can just do 180 take away the other angles, right? The other two angles. So if I do then the angle ABC2, which is that angle, and the angle at B here, it's going to be 180 take away the 30. Take away the other angle, which was this 126 here. If I do that then, I get 23.13 blah 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 degrees. So that'd be 23 here if I squeeze it in there. So therefore then, if we use the cosine rule, you're going to get y squared. And if the other two sides all squared, so 16 and 10 again. 16 squared and 10 squared, take away two lots of 16, 10. Cosine of this angle, 23.13. If I do that, put that in the calculator, I get 61.723, blah blah blah. So if I square root both sides, I get 7.856, blah blah blah, kilometers. Okay, right. So then, I've got these two distances then. So x is this 19.8, right? And the y was this 7.8 at 7.9 if I round it. So then I need so I've got the distances between A and the C1 and the C2, but it wants me to work out the distance between the 2 points of C. So in other words, the distance distance between C2 and C1. Well, isn't that just the same distance then between overall between A and C1, which is X, right? Which is this 19.8. Take away between A and C2, which is Y, which is this 7.9. So then if I do the distance between 2 points then, so the distance between C2 and C1, which are the two possible points of the shape, and I can just, it would just X take away Y, right? It would just be this 19.8 take away the 7.9, right? Hopefully you can see that, as that will get me this distance here between C2 and C1. So that will be 19.856, blah, 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 take away the 7.856, which I just worked out. And so then that would be 11.999, blah, 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 kilometres, right? And then that'll round up to 12.0 kilometres to say 3 significant figures. And there we are then. Okay, another not so nice question. But really the central idea here is again the fact that the two angles gives us two possible triangles here, right? These two triangles, which in turn gave us two positions or two points of C, because the angles are different, so the side here is different as well. So then the difference between those two distances gives me the difference between the two possible positions, right? So the difference of the two lengths gives us the distance between the two possible points, right? That makes sense. And so there we are. So we've got to an answer of 12. Right, okay. So there we are then. Let's finish off with an exam question. We are given a parallelogram PQRS with area 50, and we're given some stuff about the lengths PQ and QR. First of all, what's to find the size of angle SPQ to do decimal places. So again, probably best to draw like a rough little idea of the shape, right? So it's a parallelogram, so it's four sides. So we have PQ here, and then R is say here, and then it's going to be parallel, so it's going to be matching, right? So it's going to be S here, PQRS, and then we join it. So I get this parallelogram circle. There we are, this parallelogram shape. So PQ, no, that's P. Why have I done another R? PQ is 14, QR is 7, and angle SPQ, so the angle's at P, because P's in the middle here. I can call that, say, theta. It's obtuse, so I need to work out the angle then. Right. Well, right off the bat then, because it's parallelogram, because obviously this side is parallel to that, and that side is parallel to that, as a parallelogram is. The pair of sides are always parallel. That has to mean that the opposite sides are the same as well, the same length. So it's going to be 14 here and 7 here, kind of like a rectangle, right? For that to happen. So the pair of sides have to be the same length. Okay. So that actually makes it a lot easier then, because then if we say so then obviously we can draw a triangle then. So obviously the best idea is to draw a diagonal to create two triangles. Make that bit better. There we are. Okay, so we create two triangles like that. So now we've got triangles, triangle here and a triangle there. Okay, but we're also given again the area of the parallelogram is 50. Now in this particular case, because all the sides are sort of the same, right? If we draw a diagonal, that the triangles here are equal, so we can split the area into two. So then the area is 25 centimeters squared here and 25 centimeters squared there. But therefore then that this triangle we have then QPR or QPS, sorry. This is theta. we know this is 14 and that's 7. It doesn't look it, but it doesn't have to be a perfect, accurate sketch. And the area is 25. Why can we not use the half AB sine C for the area then to get some sort of equation? Therefore, we can say then that 25 is a half AB sine C. And so in this case, the angle theta and the two sides next to it are 14 and 7. So therefore we get 25 is a half lot of 7, 14 sine of theta. So therefore then we get sine theta. No, sorry, we get 25. Half times 14 is 7. 7 times 7, so we get 49 sine theta. Therefore sine theta 25 over 49. So then if we do the inverse sine, we get theta is 30.677, blah blah blah. But again, there will be a second possible solution for the angle theta, it's sine. So if we look at the sine graph again, in 80 and 0, the first solution is 30, that's going to be about there. So then if we read off, the next solution is going to be there for theta. 30.7 there. So the next then the next solution is going to be 180. Take away this. If I do that on the calculator, I get 149.322 blah blah blah. So I've got two solutions then. I either got this 30.677 or this 149.322. Which one do I take? Well, in this case, it told us the angle's obtuse, which means it has to be bigger than 90. And less than 180, obviously, because then it would reflex, but you know what I mean. So above 90, well, therefore we have to take this bigger solution then. So theta is obtuse. Therefore, theta is 149.3 degrees to 1 decimal place. So two decimal places. So that would be 32 degrees. There we are. Okay, so that's part A then. Part B then, 149.32. Okay, then it says for the length of the diagonal SQ. So that'll be then X here, right? But in this case, we know what theta is now. This theta, we know is 149, roughly. So now we're in a case where we got three sides we're dealing with and an angle we know. So that will then be the cosine rule we can use to work at QS. And obviously the angle's facing it. So then we could say that by the cosine rule, we can then say that x squared is going to be the other two sides all squared. 14 squared adds 7 squared. Take away two lots of 14, lots of 7. Cosine of the angle 149.322. And so if I put all that in a calculator, I get x squared is 413.57 blah blah blah. So therefore x then, if I square root that, I get 20.336 blah 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 meters, is it? Centimeters, okay. Well then, that's the length SQ then, that's the diagonal, that's the length SQ here. So therefore, to 1 decimal place, we can then say that therefore, diagonal SQ equals 20.3 centimeters to 1 decimal place. And there we are then. Okay. Right, so that is everything to do with triangles done. I don't think we look at triangles again in the whole course actually for year one and year two. So that's the triangles bit done with cosine, sine rule, half AB, sine C, and then we looked at more complicated problems today, where we merged, we used them multiple times to work out combination of missing sides and angles, and in these sort of problems that we looked at. Hopefully, this has been these examples have been useful. Bit unfortunate some of the numbers weren't nice. I can't help now the examples that were given. Um, but yeah, hopefully you learned the store function that will come in handy. At certain points when we need to reuse our workings, particularly with longer questions. Um, but yeah, hopefully now you have a good idea how when we can start to use, or when you can spot using the cosine rule, the sine rule, and the half AB sine C for the area, and you can work that out quite quickly. And so yeah, so I'll see you next time.